this evening. I was intrigued when Richard asked if I'd give you a little bit of an insight into the rolling stock world. But really happy to be here, and hopefully we can explore this question this evening, yours or mine. Will you forgive me, please, if I sit down to make the presentation, simply because I've got a few notes on the laptop, and may at a later point just need to use my pointer, but hopefully you can see it all up there and hear me still. If I sit down, does that work all right at the back? Yep. Marvellous. Okay, so yeah, okay with that, Phil? Brilliant. Okay, so just an overview of what I want to cover this evening. A brief introduction to myself. I can never do one of these things without going back to where we started, so forgive me while I just cover a little bit of history, but I'll whip us back up to date and just have a look at where we are at the moment. There's a bit of an excursion into carbon, climate and the environment before I look at the railway as a system and consider some safety and Great British Railways. So I'm scooting around quite a lot to start with, but really what I wanted to major on are the interfaces that are important to the railway as a system, and particularly working for a train operating company, the interfaces that are also important for customers. I thought it might be useful then to come back to the question that I posed, yours or mine. We'll have a look at some standards, I promise you, very briefly, and then I'll just summarise. Is the volume still right at the back? Yeah. Brilliant. Okay. So a little about me. Where did I start life? So I actually started out with the British Railways Board as a sponsored student. Absolutely loved the training programme and all the things that I could get up to. So I got a BEng from Brunel University, but the really exciting bit for me were those summers in the Brel workshops. The way my sandwich course worked, I ended up in the locomotive workshops in Doncaster and the carriage works in York, which was quite unusual because virtually all the sponsored students ended up in the derbies, the loco and the carriage works. So I was a little bit unique, and if you showed some interest, you know, you'd be shown an awful lot by the people in the works, and it was pretty well individual special treatment, and I've just never ever forgotten that. Lovely times and a lot of experience to gain in a short time. My first role was with freight locomotives at Cardiff Canton in the technical office, which fairly soon pushed out into the production manager's role. It was interesting. Some weeks in those days I could get home at the end of the week and I was trying to reconcile how I'd been into work on 11 occasions, but we've got rules around fatigue now, so doubling back doesn't happen, or shouldn't happen. Probably my favourite job, if ever I'm asked, is this one. So I went down to West Wales as the area engineer at Margam and basically ran the freight railway between myself and a train crew manager for 3 years. And you know, having your own railway, not quite to play with, but certainly to manage, was an absolute highlight. I should add that I do still live in South Wales, so you might find through the presentation it does keep gravitating back that way, but I won't apologise for it. I had a move then up to the West Midlands. Pre-privatisation, the freight railway was starting to form itself. Transrail was out there, and I was asked to manage the loco depot at Bescot and Chester wagon shops, which is actually, Malcolm, where I first met you. I was working in Bescot at the time, and got sent on a mission to go and talk to a man about brakes and a Kirov crane, and that's how I bumped into Malcolm. But I've got to thank Malcolm because he'd got, and I can't remember the name of the publication, Malcolm, the PWI Track Engineers Handbook.
Yes.
Absolutely fascinated me as a science geek. The geometry that was in there around layouts absolutely captivated me. So I think that's probably what sparked a little bit of a greater interest in infrastructure. Privatization happened. I got scooped up by Ed Burkhardt and the Big Red Wisconsin Army, and ended back in South Wales. Had a move to Eastleigh. I was covering Barton Hill and Didcot at the time. And then, strangely, to a lot of my colleagues, I got a job as infrastructure services manager, which put simply meant I was working for the freight company selling ballast trains to rail track as it was at the time. But it was actually a means to an end. I realised that I got virtually no commercial experience whatsoever. The railway was privatised, and it was obviously a competence I needed to gain. So that was a means to an end. But I grew, unfortunately, disillusioned with EWS as a company. I won't dwell. And a job came up in Great Western Railway. They wanted someone that had experience of traction and rolling stock maintenance, overhaul and repair, projects and commercial experience. I put in, I was lucky, and I ended up managing a £20 million upgrade to our HST fleet. Things moved on. I became fleet engineer. So in simple terms, I managed the 4 big intercity depots before popping up in my current role. So very potted, but that's me. And as with some of my friends in the room, of course, there's the unpaid jobs as well. So I'm currently deputy chair of the railway division of the IMechE, and that is set to change in June when I chair the division. So when I mentioned earlier in response to the question, might I want to consider helping out at other times, maybe, but I'm going to be a little bit bushed over the next year, if you'll excuse me politely declining. And I also currently chair the Railway Engineers Forum, but I can explain a little more about that later. Anyway, just to whiz you back, we shouldn't forget that our railway system is actually the oldest in the world. It's grown up from wagon ways through tram roads, so I needn't lecture you as permanent weight professionals, but two horses side by side in a cart, and yeah, you roughly getting old money for 8.5. First locomotive hauled freight train in the world ran on the 21st of February 1804 on the Panadaran Iron Road. A few years later, of course, followed by the Stockton and Darlington Railway, and it's taken off since then. But just maybe to bring us together, you'll have to forgive me.
You're going to make this hard for me to follow online now.
No, it's all right. So we should be back where we were. It's all right. I wasn't in presenter mode. Forgive me, please. Yeah. So is that all right with you, Phil? Yeah, it'll all follow. Don't worry. So I just wanted to talk very quickly about the Panadaran Iron Road, simply because this is really where I see rails and locomotives first coming together. So the pictures that you can see are actually a monument that's in Merthyr Tydfil that commemorates the Panadaran Iron Road. And this was Trevithick at the time, so it's a Cornishman in South Wales. he was playing around with high pressure steam, but for steam powered machinery in the ironworks. He was working for Humphrey in one of the ironworks, and one of the other ironmasters had actually got a grip on the Glamorganshire Canal, so the route for the iron from Merthyr down to Cardiff was under the control of one of the other ironworks. And how could the Penydarren actually get its iron down to Cardiff and bypass the Glamorganshire Canal? So simply Trevithick used his high pressure cylinder, turned it on its side, put it on a chassis, and you can see a model of the loco there, and there was the formative loco for the Penydarren Iron Road. It was a bit of a strange contraption. The crankshaft was at the front, which led to it having almost a trombone-like appearance at the front. And because it was single cylinder, it had that whacking great wheel at the back, the inertia of which was intended to balance out the action of the single cylinder. In terms of track, of course, it wasn't track, it was plates that people laid, plate layers. Again, I needn't tell you that. 4'2" inside the flanges, 4'4" over them, 3 foot long, 56 pounds, spiked to, hopefully that works for you. Sorry, Phil. Spiked to stone blocks. This was quite interesting. So I'm really back to rolling stock now. Trevithick wrote in 1804 to a close friend of his, Davis Gilbert, who went on to become president of the Royal Society. And this is as it's quoted. We've tried the carriage with 25 tons of iron, and we found we were more than a match for that weight. And this was the moment of brilliance. The steam is delivered into the chimney above the damper. It makes the draught much stronger by going up the chimney. And that principle of using the exhaust steam from the cylinders and blasting it up the chimney and creating a draught through the boiler has essentially stayed with steam locomotives. So forgive my excursion back into history, but I really just wanted to bring track and train together. And with my connections in South Wales, that seemed rather a neat way of doing it. If any of you are interested, you can actually see part of the Iron Road. So there's some views here, which I took between Merthyr Vale and Quakers Yard on the Taff Vale line, and you can clearly see the formation. And it was only on a recent trip that I realised in the right-hand view here, there was clearly a turnout there, and that was something that I hadn't spotted before. I thought I'd better leave you a bridge. I rather like this one, so this is a little further down. You can see from the map on the right, if you do want to go up there, I'd recommend starting at Merthyr Vale. You're then going down the valley, down the gradient, and you walk all the way down to Edwardsville or Quakers Yard. Nice little Sunday afternoon stroll. So anyway, that's how I saw us coming together with track and train. But where are we now? So that graph that you can see is millions of passengers conveyed annually by the railway. So the comment I made about railways rapidly taking off, I think, is fairly well made in the 1800s. There was clearly a peak around the war, the First World War, and that really wasn't recovered during the grouping era in the 20s, 30s, and 40s, and from there it was really a decline up to privatisation. The good news is, of course, that we surpassed all that pre-COVID until the point here. And then, of course, ridership went down. But the really good news is that only in the last 3 or 4 weeks, the total number of passenger bums on seats, if I can put it that way, is back to where it was pre-COVID.
Just GWR, is that?
That's a national statistic.
Wow.
That in itself is true. However, leisure travel now, believe it or not, is at about 125% of where it was pre-pandemic. Commuter and business, it is a lot lower, and the revenue, unfortunately, has followed that as well. So revenue is really only around 80% of where it was. But interestingly, our passenger demographic clearly has changed. So we've got a lot more leisure passengers. They're all travelling at weekends, and to be honest, some of you might experience it. The railway is really quiet during the week. So that's one of the challenges for the train operators. You know, how do we not reinvent ourselves, but how do we match the demand post-COVID? And you know, that's exercising quite a few. So that's where we are. I did say that I'd touch on carbon, climate, and the environment. So here on the left, we've got the Department for Transport's decarbonising transport paper. This is July 2021, and the accompanying policy statement. So you're probably aware this was born from the Williams plan. Another minister did put his name to it, but is out of the frame now. Set within that, recognising that as of 2019, rail only contributed 1% of greenhouse gases in the UK, is clearly a plan to make the railway even greener and seek to shift both freight and customers modally from wherever they are onto rail. It's got within it a plan by 2040 that diesel trains are gone, and by 2050 that the network becomes carbon net zero. I guess if I opened it up, there's plenty we could debate around that, but that's the plan that that the DFT have set. I'm not going to read this one out, but this is the Rail Delivery Group's Why We Mean Green. We are already green. There's a tremendous amount that rail, both in freight and customer terms, can do to help the country's transportation green credentials, and that's why we'll read the bit in red at the bottom. We want more people and freight to switch to rail. I think I've probably answered the question at the top of the next slide, why switch, but I think it's brought fairly starkly home when you look at that graphic that covers cars and taxis, aviation, HGVs, and here we are, this tiny little circle at the bottom. So we're already green, but you know, we need to bring people across to rail to help the country's plan. So that was a little bit of a whistle-stop tour of a background as I saw it, rather potted. But of course, that does set us a challenge. And it sets us a challenge in the context, as I see it, of the railway as a system. I've got to give credit to the graphic, to its owner. It's not mine. It's Professor Felix Schmid, who's a good colleague of mine. But I think that this quite deftly and neatly geometrically packages stations, infrastructure, trains, their management and maintenance all into one. So how are we going to get there? Well, we've got to continue working together across the different interfaces in that model to ensure a few things: ongoing safety, cost efficiency for sure. The DFT have ploughed an awful lot of money into shifting fresh air during COVID, and we can't continue to enjoy that sort of level of support. Performance for not only our customers and other customers in the UK, but also the important freight. And for train operators, comfort for passengers as well. So I've done the presentation on a company template, but I do want to stress that this is a personal observation. Since privatisation, and of course you'll understand I've seen both before and afterwards, we've got more interfaces in the industry than ever before. Nearly all of them have got a financial markup because there's a commercial contract at the boundary, and a significant number of those interfaces contain a safety risk. So why on earth have a business model like that? However, the UK railway system is not inherently unsafe. It's worth stressing. How safe is it? ORR in May last year said that Britain's railway remains one of the safest in Europe, and their analysis using what they call whole society risk places us first, and that's risk across a number of measures. And you can see in the table there where we rank comparatively well with a lot of other networks within Europe. So another personal slide now, and this is a hope of mine, having talked about markup and risk at the interfaces. So my hope simply now with GBR as a transformation team, and hopefully an entity in the future, is that they'll actually reform that number of interfaces. I'm not seeking renationalisation. I just think we've got far too many, and if we can bring some of them together under the right single roof and integrate more of the UK system, we've got an opportunity both to reduce costs and of course maintain and further improve the safety performance of the UK rail system.
Yeah, absolutely.
Nice to be amongst friends. So I'll nip back to Felix's model now, if I may, because I did want to talk about the railway as a system, and I thought it might be useful for us, with, I guess, you mainly infrastructure engineers and myself as a rolling stock engineer, just to explore them. Traditionally, we think about the wheel-rail interface. One of the two I've arrowed, of course, the other one is on the other side of the axle on top of the other rail. But there's a whole load of others that really we mustn't forget. We've got these newfangled electric trains. It's all a bit of a new phenomena to me, but they've got this pantograph on the top, obviously picking up the 25 kV overhead. So that was a whole new ball game for my team. They've suddenly got to understand pantographs and their interaction with the overhead wire. We very nearly had a flirt with the third rail with the Porterbrook tri-mode 769s. Yeah, okay, I take it from the response some of you are aware that that flirt won't come to fruition. But that is clearly another interface between the collector shoe on the rolling stock and the third rail. But there's others, you know, signalling seems to be, how can I put this gently, migrating out of boxes and control centres and more of it ending up on the train. So there's really one there where the system is split. Train protection systems are very similar. Oh, here we go again, train to structures. You know, there's another interface that that we need to get right. And of course, thinking particularly of our passengers, train to platform, that interface where we've got a stepping distance. So I'm not going to go through this slide now, but they're some of the areas that I just wanted to explore with you. Hopefully you'll bear with me while I do, and occasionally I do need to recognise that things can go wrong, and I'll maybe just draw out some of those when it's gone wrong, because they're interesting. So here we are. My wheel, your rail, there they are together. But when I say together, they're not really very together. And I think this is an absolutely brilliant photograph that exemplifies the contact patch, because it's there, but it really isn't very much. About the size of a 5p piece. Just out of sheer interest, a couple of weeks ago when I was putting this together, I thought, I wonder. So I thought back to my days when I was in West Wales in Margam, and one of the contracts I had was to maintain the then British Steel owned iron ore tipplers that were taking the imported iron ore from the deep harbour in Port up to the steelworks in Llanwern. We filled them to less than a quarter full by volume, but they grossed out on weight at 102 tonnes. That leaves you with a 4-axle vehicle at a 25.5 tonne axle load. And I was quite staggered by these numbers. The pressure in that contact patch is 0.3 gigapascal or 41,500 psi. And I'd not crunched those numbers before, but I thought you might be interested in them.
I very briefly interrupt you, Andrew. Sorry, Brian, could you turn your camera off again, please?
I thought you might be interested in them, just to maybe put into context some of the things that happened to the rail. I don't want to talk too much about the infrastructure. You asked me here to talk about vehicles, so let's just look at the other side, and I'm just going to talk briefly about wheel profiles. Please don't try and take in all the information that's in that table. I've actually lifted it out of Great Western Railway's wheel set policy. So really all I'm trying to demonstrate to you is, aside from having quite a vast fleet that's disparate from shunters and traditional locos through HSTs, modern IETs, multiple units of the diesel and electric variety, we do have a number of wheel profiles. Most of them are P8 as we know them. So what does that actually look like? So on the left there, it is the P8 profile. You can see the flange on this side. You've got the tread and then the wheel face running off here. And very much as infrastructure engineers need to do in terms of measurement and geometry checks, we have the equivalent for wheels. So a couple of the important measurements for us are this one here, flange thickness, the width across, put my teeth in, the width across the flange, and the height of the flange. There are numerous others which I won't run into. I will just disappear into education of younger people, if I may, at this point. One of the interesting experiments, particularly with younger people, is putting a pair of wax or polystyrene cups together and running them down a pair of garden canes or runways like that. It's quite an interesting one, but it does exemplify the fact that if you have conicity on the wheel set, so the tread isn't parallel with the rail, but rather it's slightly coned away from the centre. If you set that combination of cups running down that runway at an angle, fairly quickly it will right itself centre and run on straight track. The other reason for that is cornering. You'll probably appreciate that the two wheels on an axle are fixed. One can't rotate independently of the other. For obvious reasons, we tend to like to have our wheel centres fairly tight on the axle. It's not good if they start drifting off. But when cornering, as you can see in the right hand diagram, the one wheel is running on a smaller diameter than the other, and that allows us to corner. Of course, theoretically, on straight track, we don't need the flange. If the track's fine, the tread's fine, on perfectly straight track, those wheels will just run. But I don't think anybody's ever really had thoughts of moving away from flanges. So what sort of issues do we encounter at that particular interface?
Just going to try one as well. Brian, are you able to turn your camera off, please?
Okay. So predominantly wheels wear both on the tread, this portion or that portion there, and also the flange. I've borrowed from my colleagues at the University of Huddersfield. They're part of UCRIN, the conglomeration of UK universities that have an interest in rail, and they do an awful lot of wheel rail studies. So what I've borrowed here is a chart of a P8 profile, the black line, and as it wears, particularly the flange, you can see this green dotted line, and it's becoming narrower and a little more pointy. I did find a wonderful photograph of a sharp flange, and you can see that there. Does it matter? Well, probably. And yes, clearly, we don't want sharp flanges around on the network. They have a tendency, particularly in yards and sidings, of finding their way between slightly adrift switch rails and stop rails, and then the inevitable happens. So just looking at the geometry from our side, and I think this was where, Malcolm, I was inspired by the track geometry book and started getting into wheel geometry. So when the wheel has a thinner flange, you end up with a greater flange angle. The red portion there becomes sharper, and as a result of that, this angle here, the flange contact angle, also becomes larger, where the side of the flange is just on the rail gauge face. That can lead to flange climb, derailment, either on sharp curves or where you've got particularly high lateral forces. It can potentially happen at speed. So where we've got as rolling stock engineers vehicle-based lubricators, then that's something that we need to maintain for that interface. I've talked about split points, particularly in yards and sidings, and I promised I would talk about when things go wrong. So I hope they'll forgive me. It is in the common domain. If you do want to go and look on the Rail Accident Investigation Branch website, I'm sure some of you have found your way in. There's a plethora of historic investigation reports, the vast majority of which are really interesting. But there was a locomotive derailment just outside what's known as Roberts Road Depot in Doncaster. So this is on the curve just south of the station where the line to Mexborough, Aldwalk and Sheffield peels off. And it involved a vehicle that had recently had its tyres turned. There is a lubricator for the sharp curve, but the lubricators for the normal direction of travel from Doncaster through the curve towards Mexborough and Sheffield. And to come off the locomotive depot, you essentially run, signal to hasten to add, for a short way, wrong direction. So you're running towards the lubricator at the far end of the curve. And the interesting point here, which is something as rolling stock engineers we'd not really looked at before, was that the surface roughness left on the surface of the wheel profile after turning was that rough that it had actually created mini teeth that had enabled the flange to climb the rail and come off. So, you know, there was a little bit of learning, and that was a new one for us. Some other wheel wear that we can suffer is a false flange. You can either get them through running, where the tread of the wheel is literally worn that much that there's false flange around the entire circumference of the wheel, or in this case, you can see the false flange here and a fairly hefty wheel flap. That's a corker, that one is. I've seen worse, but that's not good.
Only in derailment reports, I'm guessing.
Yes. Unfortunately, these do still happen. I mean, the key one really is freight trains out of freight yards. So if the technician at the departure yard hasn't done his roll by check just to make sure everything is rolling by and not sliding by, this gets discovered. So there was a derailment in Scotland in October 2018, and this is the wheel involved. It was actually on a trailing point at a station. So what you can see there is an image that shows the two stop rails on the outside, and you've got the switch rails. You'll all obviously understand this inboard. That the wheel set's moving away from us, and you can see that false flange that's on the left-hand wheel in the main diagram. You end up running towards the toe of the switch, and that false flange isn't allowing the wheel to slide onto the head of the stop rail, and it simply pushing the fittings apart, if I put it simply. And that one derailed, but then re-railed on the next facing point. So that is a real issue, and one that we need to bear in mind. But as vehicle engineers, you know, how do we actually get around that? Well, we need to keep an eye on that profile, very much like rails. You know, that there's a new profile, and there's limits that we can allow it to wear before we've got to do something about it. So the image I've just lifted straight out of our Halfords manual for trains for HST power cars, and we do periodically gauge them. And the gauge you can see there, there's a couple of little sliders. There's one there that's in contact with the tread, another one there in contact with the flange, and that simply measures the flange height and thickness. I've left you the manual version because it's easier to visualize, but we've now got the modern version that's magnetic. You clip it on, it's laser measurement, and then via the Wi-Fi it just pings the information to a central database. But I just thought if I went old school, you can see what's happening. What do we do when we end up out of limits? Well, the wheel lathe comes into its own. Most rolling stock depots these days will turn wheel sets whilst they're under the vehicle. It's obviously an expensive and laborious exercise unless the wheel's worn to take it out, to reprofile it, to put it back. So what you can see there's an underfloor wheel lathe supplied by probably the prime supplier, Hegenscheidt, in Germany. Other suppliers are available. Down the road in Reading, we've got a Danabat wheel lathe supplied by a Spanish company. They'd supplied oodles of single-headed wheel lathes for trams in mainland Europe. And for a reason I really still don't understand, we decided to buy their first twin-headed wheel lathe. So I'll say we were guinea pigs and I'll leave it at that. But essentially what you can see here, obviously, that the vehicle is driven on or pushed on or hauled on. You've got a couple of sections of rail that once the vehicle's there and the wheel's supported, slide away, and turning tools come up from underneath and turn the wheels. That's a single-headed lathe. A twin-headed lathe will deal with two axles at once, so you can turn a bogie rather than just a wheel set at a time. They're computer controlled. In theory, you get a perfect profile. Experience tells us that it's always just best to check that you've got what you wanted. So to do that, just go back old school. We've got profile templates, just pop it on. Can you see daylight through it? I'm being a bit melodramatic. We do that after the first turn of a profile, but we do assume that the machine can continue to turn to that profile unless we go for another one. And if you go back to that table a few slides ago, there are a few different profiles. Locomotives have got a P1 profile, and the astute amongst you, when you read the top line for the 08 shunter, you'll have noticed it was P1, P9, P1, and the P9 in the middle deliberately has a thinner flange to enable that short fixed wheel-based shunting loco to go around tight curves. Could you pass me my water, please? Are you all still with me?
Yeah.
Oh, brilliant. Brilliant. Thank you. So where to go next? I thought I might get a little bit of sympathy if I went here. Okay, maybe some understanding. So yeah, we suffer too is the answer. So there's a wheel tread, but some bits missing from it quite clearly. So yeah, I thought this might be a useful compare and contrast. So assuming most of you have got an appreciation of what's going on, I'm not going to go into the deep detail, but simply cyclic fatigue and work hardening of the steel will cause shelling on the tread. We can get round that similarly to rail, and we do a lot more pre-planned tyre turning just to keep the hardened steel off the surface of the tread. when we turn wheels, if we end up with defects such as, I mean, that flat I showed you earlier was ridiculous, but we do sometimes suffer from flats, particularly if we've got a system on trains that's very, very similar to ABS for cars. And in theory won't let your wheels skid. They do occasionally. If we have to turn those out, we take quite a lot of metal off the tread. The sort of turning I'm talking about now is 3/4 of a millimetre at the most. It's literally just a tickle to take the hardened steel off the outside. But as well as experiencing RCF in the sort of running band of the tread, that central portion you can see in the upper diagram, we suffer on curves. And I don't think curves are really very useful for either infrastructure engineers or rolling stock engineers, but they're a geographical necessity for the railway in the UK. It might change in the future, but we are where we are at the moment. So curving forces also cause us issues, as you can see in the lower picture there. Usually off centre towards the field side, and they're generally, unless you've got a steering bogey, and I'll cover that in a short while, it's associated with the trailing wheel of a bogey on the low side rail, and it just simply has a harsh angle of attack onto the rail that causes it and leads to those sort of chevron type indications that you can see there. They don't actually look much, but in the upper picture there's some fairly obvious damage. In the lower picture you can get subsurface cracking that's actually more extensive, and then you don't really realize it's there until a chunk falls out. So that's why, not wanting that, we've got planned regimes for tyre turning. I think this is probably just going to repeat a lot of what I've just said, but really on the other side. So it's just recognizing that that the phenomena clearly exists in rails as well, and there's a huge load going back to that contact patch and the 0.3 gigapascal of the 41,500 psi that we're fairly transiently transmitting to the rail. I mean, it's a clatter, 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 and the train's gone. I oversimplify, but that cyclic loading it isn't helping the rails either. And as we've seen, rails that suffer from RCF, particularly on the surface on the gauge corner, that can lead to gauge corner cracking, and we know where that went with Hatfield. And post Hatfield, of course, there's been a huge amount of work, both in infrastructure terms and rolling stock engineering, to make sure that wheels and rails don't go there again. Here's a good question: wheel steel versus rail steel. I'll go you and mine again because it's kind of in the title of the presentation. So to combat wear, if you make your rails harder, then surely my wheels suffer and wear quicker, and the problem's mine. But do I actually combat that? So, I'll just go for a harder wheel steel, tough for your rails. It is an interesting one. So, here's the physics. Where's a direct combination of two things: the forces generated in the contact patch and the way the material responds to those forces. So if one material or other is made more wear resistant, then okay, its properties have changed. But if the wheel rail profile stays the same and the contact point stays the same, then the total forces remain the same. And essentially, one side of the interface doesn't know about the hardness of the other. So it shouldn't be expected that hardness causes more or less wear. And I've actually proudly stolen that. So thank you to Dr. Mark Burstow from the VT-SIG. Noise is another issue for us. Wheels and rails aren't entirely smooth, so the contact between the two causes slight movements. Those slight movements cause vibrations, and the vibrations cause noise, which some radiates into the air, some becomes vibration and moves into the vehicles, and that increases with increasing train speed. I was on a journey of discovery putting this together, so I'll readily admit I didn't know this bit, but I thought it was worth putting in. The Environmental Noise England Regulations 2006, maybe it's because I live in Wales, I don't know, require noise maps to be produced every 5 years. I had absolutely no idea. DFT and ORR are required to investigate locations with the highest noise exposure. Interesting one. So hold that thought for a minute. One positive side effect of rail grinding in response to rail RCF is actually smoother rails. So it's a double win there with reduction in noise. Standards for rail vehicles are becoming more prescriptive now. So they also ask us to consider noise. And I did say I briefly mentioned standards. I'm not going to dwell on them, but there is one at the bottom of the screen there. The bit you might be more interested in, because I thought I could bring noise home to Reading, and indeed I have. So there you go. There's the result of the latest survey. And I did a little bit more learning. In some of my training, I interestingly ended up, I'm going back too far that I almost can't remember, but I ended up in a part of the tech centre that housed what was known as the environment section. Ostensibly, I was working on air conditioning systems, and one that I wasn't allowed to talk about, but I think I can now. It was an aircon system for one of the Royal Train vehicles, which was super interesting. But another part of the section dealt with acoustics, and of course I couldn't help but find my way in there and talk to them as well. And what I found here in noise measurement was an LDEN. So some of you might be familiar with LEQs, equivalent noise levels. I haven't got a clue what an LDEN was, but apparently it's an equivalent day, evening, night, DEN level, where the measured noise level is weighted, but it's weighted and penalised slightly more for the evening and a lot more for the night. So now looking at that map, and all this on the upside, west of the station down to Scowers Lane, it made me wonder where it was coming from. The answer, of course, is obvious. It's our depot. But I just thought bringing it home to Reading, that might be of interest. I'll move on quickly. I'm just going through some other of the passenger issues. So ride and stability, acceleration has an effect, vibration, noise we've covered, oral pressure, that's an interesting one. Have any of you been on the IETs and been in the vestibule just as it leaves a station or just as it comes in, and there's a bit of a sort of clunk around you?
Yeah, I definitely recognise that.
So that's the door seals. So the vehicles themselves, actually use the speed sensing, and once they're at speed or not at a standstill, essentially there's a better seal between the door and the car body to reduce pressure pulses. So unlike other rolling stock, you shouldn't get your ears popping. Not that IETs go through dim or tunnels, single bore tunnels, but that's what it's doing. So that's addressing oral pressure. Lighting in vehicles is important, as well as the interface pressure. The seat, and I'm definitely not opening up the debate around seats tonight, but I'm sure someone might want to press me. What I wanted to look at was ride stability and accelerations. So there's a simple bogie there. You could say it's a freight bogie. Loads from the track through the wheel set hit this green frame, and you've got these yellow stack springs running onto a bolster that then marries with the vehicle on that pin on the centre casting. So that's a freight vehicle. You've got a little bit of reaction here and here on the side bearers to give it a little bit of yaw stability. Passenger vehicles, it's much simplified, but where you've only got primary suspension here, which is mirrored by these springs here, you've actually got secondary suspension between the bogie and the vehicle. It's shown as a spring. These days it's usually a stack of either rubber chevrons or an inflated pneumatic bag that looks a bit like a large bowled tyre for a car. So suspension is not only important to us, but also the infrastructure. It isolates the vehicle to a large extent from force input from the track, and equally helps reduce input to the rails from rail vehicles. I did say I briefly mentioned self-steering bogies. So where can rolling stock engineers help? We have a bit of a whiz in. Sorry, Phil, you can't do that, can you?
How did you do that? How can I copy that on your presentation?
All right, don't worry. So in essence, what you've got here is a linkage between the axles that actually allows them to split and not run parallel when you're going around corners. That makes it much more friendly, and it also helps in reducing RCF from that trailing wheel low side on canted track. What else can we do? Sorry, I'll do it again to you now, Phil.
Are you pressing to do that?
I'll tell you later. This is a bogie off an EMU, really just to give you a little bit of a feel for what is underneath. So in the simplified views, you saw the prime. Is my hand up there behind me on the presentation?
We've had the red dot.
It's not.
But
All
I can't
right.
see it this time.
Okay, I'll come out of that and use the dot then. So there's your primary springs. Your secondary suspension is that rubber airbag, but we've also now got these grey components, which are dampers working with the primary suspension. So if you're into cars and car mechanics, you've got a spring and a shock on the front. That's the spring and the shock. It's as simple as that. We don't really help things though, because we've got these whacking great electric motors which are putting a whole load of weight in, but we've somehow got to get the drive down to the rail wheels. So traditionally, if you looked at one axle and that motor from above, the motor would be mounted on the bogie here. That's nose suspended in our terms. But the other end of the motor, look what we've done. We've wrapped it around the axle. So virtually all the weight of that motor's on the axle, and is directly bearing on the track. It's the track side of the suspension, not the the vehicle side. So more modern designs, you can see here the motor's completely separated, mounted on the vehicle body, and drives through a gearbox. Interesting little excursion now. This guy. Anyone any ideas? Wilhelm Jacobs. He was around and prominent in the 1880s. As you might have guessed from his name, Centralist European, German engineer, who went to the Gewerbe Academy in Berlin, and worked on locomotive construction in Hanover, and became a senior official within the German railway in Cologne. I use the German pronunciation of his surname, but some of you might be familiar with the Jacobs bogey. So that's Wilhelm Jacobs. The Jacobs bogey is in the upper part of the diagram, where two vehicles share one bogey, rather than traditionally each vehicle having a bogey at the end. So how does this affect things? Well, it's got an awful lot of advantages. Believe it or not, there's some safety. So there was a Eurostar derailment in 2000, where Jacobs bogies were employed, and they actually kept the train upright and in line running, rather than the traditional concertina derailment pattern you can see. Clearly, there's less weight. It's simpler to construct the train. It's a lot cheaper to build and maintain as well. Fewer wheels, less rail noise. But there are disadvantages. It makes it difficult to lift vehicles, because you really can't. You've got to lift the entire train at once. And I've got to be sympathetic. Obviously, it doesn't help, because the train weight's the same and it's transmitting its weight to the track through fewer axles. But that's an interesting one. It is one that's not too far away from us. So I said I'd keep going to Wales, didn't I? So here's an image of Transport for Wales New Class 231, their Stadler Flirt unit. They're currently running on the Rhymney Valley. I occasionally get one into work. I've used them in Switzerland. I'm a big fan of Stadler. It's a fantastic product, and hopefully you can see from the graphic at the bottom that bogey in between vehicles that adjacent vehicles share. So it's a quick run around rolling stock, but I did just briefly want to mention some of the other interfaces. Platforms. They can be difficult for rolling stock engineers. We need to get our footsteps close to the platform. Footsteps now aren't necessarily the traditional one that's fixed on the vehicles. There's a number of vehicles that have retractable footsteps. The Pendolinos on the west coast, but that's moved on now to the trains that I just showed you for Transport for Wales, and the new 777s, a Stadler train again for Merseyrail, which have deployable retractable footsteps, but with proximity sensing. So they will go out as far as they need to almost meet the platform. And this is a particular interface that's clearly important for both of us. We don't want the step meeting the platform, but equally, and it affects us, particularly when we put rolling stock onto routes it hasn't been on before, or introduce new rolling stock, that we have both the step and the gap to manage, and that's something that we have to manage within limits. I couldn't present without recognising vehicle gauges and structure gauges. I think these are fairly self-explanatory. We need, sorry, I was going to use that slide. We need clearance between the vehicles and the structures, otherwise the train doesn't pass through through them. Interestingly, I had a little bit of a dig back, and I didn't want to use all current events. So can I take you back to January 1875? And yes, this is 1875, to a place now that's known as Pontammon, but in those days was Pantammon. This is on the freight line, for those of you that know it, that runs off the Central Wales line at Pantyffynnon and ran through originally to Bryn Aman, and latterly, whilst it was still operational, a place called Gwaun. If you'll indulge me, I will read this out because this is great. So on the day in question, a Great Western mixed train left Bryn Aman at 2 p.m. So it's heading east towards Pantyffynnon. The train was running at a speed of about 8 miles an hour when it reached Pontammon Bridge. The engine and wagons got safely through the bridge, but the roof of the carriage truck hit the face of the arch at the right side. The carriage truck had been sent a few days previously by the same line to Bryn Aman, so no issue. Except it was then loaded with furniture and the load passed safely through the bridge, but on the return journey it was empty. And the weight being taken off the springs allowed the body of the carriage to rise slightly, and the arch of the bridge was not high enough. So it's the infrastructure's fault. The bridge should have been higher for it to pass through. So that was Lieutenant Colonel F.H. Rich, acting on behalf of the Board of Trade and Reporting, but God bless him, he actually looked a little deeper and discovered that it appeared there are 4 bridges, which are smaller than usual on this section of what was the old spelling again, Llanelli Railway. So maybe there's a salutary lesson there in understanding where our assets are and suitably managing them. Quick one now. Here's another interface. It's a fairly old one, AWS, but just to show that the standards do require us to have a separation. So in infrastructure terms, that receiver, please, no more than 12 mil above rail level. But equally, we've got to keep our part, and I've gone back to our Halford's book of how to maintain HSTs. Minimum height 132 millimeters. So that only leaves us 120 millimeters clearance, or for those that deal in English, 4 3/4 inches. And that's lessened through a little bit of suspension movement. I deliberately used an old example, but of course that now goes on through more modern. What you can see there is a Belize and a data reader on a vehicle. So we're using these now, particularly for things like ASDO, as we call it, automatic selective door operation. So you might be aware, particularly if you used to travel on HSTs around our network or do still, we've the ability for the guard to select all the doors that way from where he stood or that way from where he stood. And we release that portion of the train. The selective door operation has actually expanded now such that it uses GPS to tell the train where it is, and the granularity is enough to let it know it's in Reading Station, but it's not granular enough to tell it which platform it's in. So to give it the platform information, that's where the Belize and the data reader comes in. The point, of course, I wanted to bring across is that there's an awful lot more of these items appearing on the infrastructure. So it's absolutely vital that whilst it's connected with a rolling stock scheme, that rolling stock engineers have that interaction with the infrastructure manager. Sorry, I'm getting a bit rogsy, but we have that conversation with the owner of that system to make sure that those Belize's are recognised as an asset, and of course they're maintained, particularly during things like track renewals. Otherwise the train will come along afterwards and I don't know where I am. So this is what I see as yours, if you'll forgive me. hopefully you recognise all, or at least most of that. That's what I see as mine, and I hope I've managed not to go through all of it, but maybe just give you a little bit of an insight into some of the things that need managing on the rolling stock side of the interface, as well as a few little historic excursions. Of course, the thing that we all need to recognise is that there are a number of standards that apply to these interfaces. Some cover both infrastructure and rolling stock. Others, such as, if I take AC systems, there's two there. One for the rolling stock and one for the infrastructure. So I've come to answer the question. It's not yours or mine. That's fairly obvious, isn't it? That the railway's got to operate as a system, and it's ours to manage. But we need to recognise that management and the risks of safety at the interface. Of course, ours in connection with tonight is rolling stock engineers and the PWI, and I did promise I'd come back to the Railway Engineers Forum that I chair, and it is a forum that involves all those other organisations, and I would stress, and I do like to put them on a small pedestal, we do include the Institution of Railway Operators. Despite the title of the forum, they are absolutely vital to the operation of the system, and they're a very welcome member of that forum. Maybe I'm slightly biased. I'm competent as a guard on some rolling stock on GWR, so I do see things from an operator's perspective as well, or at least I like to. Can I have an ad, please? It seems as I've got a captive audience. Here we go. There is method in the madness. So what you can see here is Viva Rail's as was battery train. This is the train that went to COP26 as a battery train and a demonstrator. You might be aware that Viva Rail are no more, unfortunately. They went into administration in December, but we essentially, on behalf of the DFT, as a train operator, have been asked to keep a specific part of their technical exploration alive, which is fast charging of the battery train. So they were 3/4 of the way through a scheme to put fourth rail in the bay at Ealing Broadway, but not fourth rail in the way that we'd all understand it, with centre rail and a third rail, but all the rails in the forefoot. So there we are. We've mixed it up and made it different again. But the point I want to get to, I didn't think I'd animated this slide, so I better crack on with it, hadn't I? And it's all coming in the wrong order. Anyway, we got there in the end. So you're all really, really welcome to the next IMechE Railway Division South Western Centre presentation, where clearly there is an interface between the infrastructure and the train, and that's being presented by a couple of the 9 individuals that now work for us that were Viva Rail. I've only got to know them over a short time, but it's absolutely fascinating, the project. And if you want to go to nearyou.imeche.org, you'll find all the details. But it's 5 o'clock in the Steam Museum on the 24th of April. So thank you for indulging me. Just in conclusion, yeah, track and train have had to work in harmony ever since the earliest days. That brilliant invention has led to an amazing rapid expansion of the railway, a railway that's really green, but it's down to us now to encourage and really facilitate that modal shift and capitalise on our green credentials on a system that's got an awful lot of interfaces, and hopefully I've been through a few that share a common interest. Clearly, we need to understand where our assets are. We need to install them correctly, maintain them correctly. We've got standards and procedures, but still things do go wrong. And when they do, I think it's fair to say we learn from our mistakes and make things better for the future. And of course, as I said, it is neither yours nor mine. We've got to manage it as ours. Can I just recognise a little bit of input from two good friends of mine, Bridget Eycoff of RSSB, and I've already given my good friend Felix Schmid a plug, Professor Emeritus of Railway Systems Engineering at University of Birmingham. I desperately need to dive into that glass of water, so that's it from me. Thank you ever so much for asking me to come to talk this evening. I hope there's been something of interest for all of you, and I'm happy to take questions now or later on. I might talk a little bit more when my throat has been oiled with something else. Thank you.
Thank you very much, Andrew. Very interesting, very grounding. I think brings us to a level playing field. I think it's important to just go back to the essentials of everything that we're out there to do. So we covered. Ready for some?
Yeah. Chucking out, mate.
Fascinating talk, Andrew, tonight. Very pleased you could come and talk about. That's just the right thing to discuss. Not your side of the house, the rolling stock side of the house, how it operates with us. What I'd like your opinion on, or your thoughts on, over the years, and certainly in very recent times, we seem to be going the way with count and count efficiency. We are pushing the bounds with count efficiency, whereas everything I was taught was that you get as near to the equilibrium speed as possible with the count. Bearing in mind we're a mixed traffic railway, so you're never going to get absolutely to it. But look at the preponderance of the traffic that's over that. Get to the closest equilibrium speed you can. That will give you the best balance overall, because it will equalise the weight on the rails. Now, as far as I'm concerned at the moment, we are pushing efficiency much higher, which means that virtually all trains now, freight trains, travel much faster than they used to do in my younger days. Everything now is travelling probably above the equilibrium speed. So the weight is generally always onto that high rail. So that's going to give us a lot more cycling and so on. That must affect your wheel set. But what's your thoughts about the way that the civil engineering side of it is going, as far as that's concerned? And we want to push the highest speeds, obviously, that is the right thing to do. But it does concern me that we don't get something like Freightliners, for instance, if we get in closer to the equilibrium count being applied, not the count efficiency, we are going to get some of the trains dropping down towards the weight, dropping down towards the low rail as well.
Yeah.
So I think you're going to get much more of a balance. I don't feel as though the balance is there at the moment. What do you feel about the effect on your wheel sets for that?
It's a really good question. Of course, if we've got all vehicles travelling at the same speed, then it's utopia for everyone, as you recognise, Malcolm. And there's got to be a bandwidth. It's interesting because I wasn't aware that was being pushed as hard as you've just suggested. But just thinking about the mechanics and physics of it, certainly for higher speed vehicles on track that's canted a little historically, should we say, it's certainly not going to help that interaction between the trailing low rail wheel set of a bogie with the rail. It's probably going to put in more slip. It's the slip that's also promoting the RCF, and it is just going to push that flange against the rail. So we've probably got that flange issue, and obviously you've got the. I'm doing the yours and mine again. It's ours, isn't it? I knew I'd end up there. You know, the infrastructure is taking that greater weight on the high rail. So, yeah, we do sometimes see what we believe are unusual wear rates on wheels. Sometimes we can get to the bottom of it, and we do talk regularly with the infrastructure managers. On other occasions we can't. But then we've got to look at all avenues as well. Wheels and wheel steels. I know I talked about hardness earlier. The specification for wheel steels is it's there and it's defined, but it's defined within limits. And we've found that you can go to some suppliers who will obviously supply as cheaply as they can within spec, but they're supplying wheels at one end of the spec. And you end up with wheels that, God bless him, as my old metalwork teacher would suggest, are made of banana metal. They're horrifically soft, and we get wear there. So, yeah, I think my thoughts would be that you know, we've got to get the system back closer to that equilibrium, and if train speed progress is running a little faster than the infrastructure, is that something that, I don't know, I'm spinning the question back now, is that something that can be done in between renewals, just having a slight play with the cant? I don't know.
A further quick comment on that is where you've got the tilting trains.
Yeah.
Tilting trains negate this business of the higher efficiency.
Yeah.
Distribute the weight again.
Yeah, so if you've got something like a Pendolino on the west coast with active tilt, their active tilt can put in the compensation to get you to that equilibrium.
Yeah, and you get the high speed as well.
Yeah. So Roger Ford's 50p stays put. If any of you've seen that one, 50p on its edge on the table, and it's got to stay upright. That's Roger's 50p test.
Okay, one from me online. Slight, nice to be a challenge to your them and us statement. I think I work in projects. I'm currently building, I'm part of the team building Cambridge South Station. There's an awful lot I do looking at the track designs, the station designs. There is a level of them and us, and I suppose there has to be, because our organisations are very different, our approach are very different. In my project world, you are a stakeholder. You are a third party that I need to talk to and appease, and absolutely there is a systems level and a systems understanding and a mutual respect for each other, I feel. But certainly in the industry where we are at the moment, there is them and us. I don't think you can get away from it. It's almost, you have to work with that, and you have to have as I said, a mutual respect. You've got to understand each other, and we do have roles to play, and we are separate. So I hear what you say, but it's not quite right. I think we are them and us. I think we have to be a them and us, but with a looking over the fence and talking with it, rather than someone trying to do everything. It doesn't really work.
Okay, no, that's
a different view for you.
No, fair enough. You know, I think I was also thinking of the the entire railway system. When I talked about the myriad of interfaces,
Yeah.
and you know, my concern is both financial and that, not that it's significant that, but that safety risk, and that there has to be a way of slimming it down. It might be that,
No, I agree with that entirely. Yeah.
you know, train and freight operators and infrastructure managers remain separate. I briefly mentioned the 777s on Merseyrail, the other Stadler flirt fleet that we've now got in the UK, and of course Merseyrail is run vertically integrated. And if I come back to the other Stadler fleet that's running in South Wales, of course the Valley Lines is vertically integrated. So I'm not going to disagree. I think what I'm going to say is there are other models around at the moment,
Yeah.
and it would be interesting to see how they develop.
Yeah. Cool. Thank you.
What are your thoughts on future traction possibilities for the Thames Valley branch lines?
Well, it was 769s, wasn't it?
Yes, it's going to be all kinds of things.
That one's disappeared. It's going to remain Thames turbos for the immediate future. The railway's got to the point now where probably fleets like, do you mind if I talk fleet classes? Is that all right? So classes like 158 and the 16Xs, the Thames turbos, have got one more refurb left in them. So, you know, they're likely to go through to 20, 32, 35, 38 between 158s and turbos. But you know, there's other rolling stock coming in. I'll be honest, in Great Western terms, you know, we're still working our way through it with the 769s not being successful. So there may be another answer in the fullness of time, but for the moment, it's the tried and tested turbo.
So I'm on the heavy branch line. So we'll have comfortable seats and space for bicycles for quite a while to come yet.
Yeah.
Good.
Are there any more in the room or out there?
I can't.
I've got one more if I can go get there's no one online, but no one from me if you don't mind.
Yeah.
It's entirely anecdotal evidence based on personal experience. Pre-COVID, I commuted. I live in Swindon, actually. I live in Swindon. I used to commute to Wales pretty much every day into an office. It was busy, but get a seat, but it wasn't too bad. Now I work part time at home. I will commute into London on a Thursday morning, and I commute home on a Friday evening. You were saying it was, yeah, commuter travel was down massively, but my Thursday morning trains are generally fairly full, and Friday evening is utterly rammed. Literally a couple of weeks ago, I had to sit on the floor in the vestibule to come home. It was just crazy. So it's interesting what you're saying about the difference between leisure and commuter, and how are you seeing that spread between maybe different days of the week or different times, and is peak and off peak changing, or what's the new way of working or new way of travelling, as it were?
We're seeing the bulk of business and commuter customers Tuesday to Thursday. I take what you've said anecdotally. Fridays pre-COVID traditionally was the, if you worked a day at home, that was the day. So Fridays were always fairly quiet. So Tuesday to Thursday are the busy days, followed by Monday, and certainly during the middle of the day, you know, Friday has dropped right off. I suspect it's probably just the peak effect, and you know, people disappearing for the weekend. But during the day, it is very, very quiet. And I was talking with some colleagues earlier around, you know, some early thoughts around how we could, you know, rejig to some extent the timetable, and also the number of vehicles we put on services to, you know, meet the emerging needs. But then we ask the question, well, those needs are what we see today emerging post-COVID, but are they going to be here in another 2, 3, 5 years' time? We don't know the answer to that question. So it's not an easy one at the moment, but yeah, Friday during the middle of the day is very quiet.
And a very loaded follow-up, if I may, about peak time pricing versus off-peak pricing and things, like advance tickets. So you can play some tunes on that to try and encourage different times of travel. But
yeah, and I think the railway is exploiting that more and more now. A lot of the train operators are putting deals on to try and smooth things out. And of course, that's one of the great things that the Great British Railways organisation is going to do, is put ticketing under one roof and get rid of this absurd situation. Got to take down the GWR a bit now and take my badge off. Anyway, personal thoughts. Yeah, I mean, this absolutely absurd situation that we've got in the UK, and I'll put my hand up. I do it if I need to buy a ticket for work travel of split ticketing. I've travelled from South Wales to places like Manchester, and I've split at Cabran, Shrewsbury, and Wilmslow, and I think last time I did it round numbers, it was down from 80 something to 54 quid. Well, that's just absurd.
I've saved over £100 on split ticketing in the past.
Yeah.
So journeys, obviously, but yeah, you can save vast sums. It's crazy.
But we're on the inside, and we can understand some of the ways around it. I mean, just with respect, put yourself into an irregular customer's shoes, and it's just completely baffling. Or they're paying through the nose, which is morally wrong, I'd suggest.
Yeah.
Sorry, you've got me way off onto a topic I'm passionate about, but
professionally, I've sat on 2, 3 different ticketing websites trying to book one ticket. It's like, I'll get an advance there, and it's different. It's crazy.
Okay, well,
if any of you do want to get hold of me, that's the easiest way of doing it. And if you do want to talk some more later, I'm quite happy to. Sorry.
So we've lost a couple already who've got trains to catch. So I think it's a good point to wind up the proceedings. So, Andrew, thank you very much. Rodney, could you do the vote of thanks, please?
Well, nice here.
Yeah, that's fine.
Yeah.
I'm gonna.
Probably on the screen,
It'll be on screen, don't worry. Don't you worry.
Well,
Yeah.
it's occurred to me just now that 28 years ago last Friday was a rather significant date in my career. Thanks largely to Tony, but that was the day I left British Rail in Western Tower, a unified organisation where we had the mechanical engineers, the depot engineers.
Got you on camera over here as well.
On the 7th floor, I think we were on the 6th floor. Signals were on the 8th. Operators were down the bottom where they should be. But did I have much to do with the depot engineers? Only when there was a new rail. And that was it your wagons or our tracks? Often it was both, and sometimes it was the driver as well, driver handling the train. We had to remember that. But 1st of April 95, as I always say, April Fool's Day, as far as the railway was concerned. It was the day the railway management went into silos, and I subsequently discovered that in Swindon office there were padlocks on the rail track doors. What became Scott Wilson, they didn't have padlocks on their doors, but the railway became disintegrated, and Andrew has concentrated on the oneness of the railway. Well, a lot of interesting things. I mean, I landed up, I think it was about 1999, working for the same boss, Clive Burrows, who was a marvellous, I hope you agree with me, I'd say he's a marvellous railway engineer. And he commissioned me with a chap called David Wilkinson, the depot engineers, to look at various issues on the track quality to start with, and then rolling contact fatigue. And that was when I began to learn that wheels don't just go along rails, they roll, and left to themselves, they go like that. I learned a lot that I'd never been taught, even seen in writing before in those few years, around 2000. But what I think it demonstrated was that the railway is one system. And I think you've been concentrating on that, and I give you my congratulations for being one of the generation who obviously doesn't think much of the disintegrated railway management system. What we're going to get, goodness knows. But I can only say that with people like Andrew looking after the engineering of the vehicles, we're on safer ground, I hope. And I hope the same is with the track. But you know, speaking in a week when we've had a major issue with a civil engineering structure at Cullen, can't really say too much about the state of our infrastructure, but I'm hoping my old colleagues and your old colleagues are working hard to put it right, and we can get trains running between Didcot and Oxford and further fairly soon, but we shall see. Anyway, thank you very, very much for giving this marvellous talk, very wide-ranging, and I'm quite sure there's one lesson: we coexist or we fail. Anyway, join with me, please, thanking Andrew.
Okay, Rodney, thank you for that. Richard, next meeting, please.
Oh, I've got a new chairman. Oh, that's good. Next meeting is, except the lights are, I can't see it. So it's the agenda gone. It is a meeting. Oh, you've got it. Thank you. Yeah, don't press the wrong switch, Phil. We've had that one's full.
Yeah, quite.
The next meeting has taken months to fix. We were going to have them last October. We were going to have them then, and etc., etc. But at last, next month, we're going to have a talk about track renewals on London Underground by Amy Pearce and perhaps another colleague. Her colleague who was going to come, Charisma Jane, is getting more and more wrapped up in the PWI's presidential ladder. So she can't make it because she's in a conference in Birmingham the day before. But anyway, at last, next month, 10th of the week after the coronation, so you shouldn't be your commitments should have been discharged, is this talk about track renewals on London Underground.
Okay.
Close of meeting, it says here.
Okay, I think that finalises everything. My thanks once again to Andrew for a very detailed presentation this evening.
You're welcome. Happy to.
Very thought-provoking, so thank you for that. Thank you to everyone else who's attended this evening. Thank you for those at home who've tuned in and supported the event this evening. We've lost a few already. As soon as the talk went, they gone. Nick, there was a chap was leaving earlier on. Said, if Nick Ramsden's in this evening, tell him he'd better say hello to me next time he walks straight past me at the football. So, I don't know. Your wife acknowledged his presence. Yeah. So thank you very much. I think we will adjourn to the ale house for a small glass of beer. So if anyone fancies coming along and continuing the discussions there, please feel free to do so. And if any of that, we shall see you on the 10th of May at the same location. Thank you very much.
Okay. Andrew, how do I get your talk onto this sticker?
You can't up here, but Philip's got the wherewithal. Yeah. Shall I finish this?